Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. And we're discussing the subject called Data Structures 2 or Advanced Data Structures. And today we are going to study or we're going to see how merge sort is implemented and what is the basic principle behind the idea of merge sort. So few lines first. Merge sort is a sorting technique based on the divide and conquer technique, as we have seen a few of the algorithms certain now, which implement the divide and conquer technique. So this is again one of the applications of divide and conquer technique. Now this algorithm called merge sort has a time complexity of uh, n log n, and it is one of the most respected algorithms. Now the basic idea is merge sort first divides the array which is to be sorted into equal halves and then combines them in sorted manner. Okay, so first divide it into equal halves, then sort the halves and then merge them. So that is why the name merge sort. Okay, so let's head back to the slideshow and we'll see. Okay, so let's move ahead with the merge sort. If you people want to write the algorithm for the merge sort, please pause the video and first write down the array A. Now this is the array A. If you can see my cursor, the array, there is the cursor. So please be focused on that. This is the array A which we want to sort out. Okay, now this is the algorithm I have written here. The algorithm has two functions in it. The first one is the merge sort itself, and what it takes is the argument you are going to pass to it is the array A itself, its lower bound, normally the first index, and the upper bound, normally the last index. Okay, and inside this merge sort, we're going to call one more function called merge. As you can see here, you are going to see one more function called merge. As I've told you before, in merge sort we first uh, divide the array, and after division into equal halves we first sort them, and after sorting we actually merge them again. So for division and all that, for division and sorting we have merge sort here. Sorry, for division we have merge sort here, and for merging we call a separate function called merge. And this function merge actually requires the parameters, that is the array A, the lower index or the lower bound, the upper bound, and the midpoint. Now, what is the meaning of lower bound, upper bound, and midpoint? We'll see in a minute. I've also explained the function merge just below the merge sort. So basically, as you can focus here, merge sort is actually a recursive function, or it actually makes a recursive call to itself. So merge sort actually implements itself by calling on to himself or itself again and again and again. So we'll see how it is being done. Okay, in a while. Okay, so let's move ahead. Now, now we have this array A. So I will first mark the lower bound as this index 0 and the upper bound as this index 8. So when I call this function merge sort, I will pass three parameters. First is this array A, which I wanted to sort out using merge sort. Then the lower bound equal to 0 and the upper bound equal to 8. Okay. Now merge sort, inside the merge sort, first we'll check a condition if lower bound is less than upper bound. That is, the lower index or the lower bound that I have, uh, the index 0 that I have passed on as lower bound is less than actually to the upper bound which I have passed on this last index of array. Now in this condition, yes it is. So we'll go inside the conditional statement returns true and will be inside the if block. Now inside the if block, if you will see, we'll first do the division part. That is, we'll divide the array into two equal parts. Okay. So for that, we'll first find the midpoint. Okay. We'll first find the midpoint of this array. Now to find the midpoint of the array, as we have seen before in our binary search, that we for finding out the midpoint, all we have to do is just add the lower bound and the upper bound and divide it by 2. Let me again tell you, this is the integer division. Integer division means it will floor the value that will came out of it. That is, if the division comes out to be 3.5, the value that is assigned to the mid will only be 3 only. Okay, so we'll shed the decimal part and stick to the floor value. I think you people are familiar with the ceil and floor concept. So the lower bound is 0, the upper bound is 8, so the midpoint will be 8 plus 0, that is 8 divided by 2 equal to 4. So from 0 to 4, now 4 is our midpoint. Okay, now 4 is our midpoint, so we'll divide this array into two parts using this 4. So from lower bound to our midpoint will form a one array, as you can see here, that is from 15th to first element, that is the fourth index. At the fourth index we have new array, or we have divided this array, and from the midpoint plus one index to the last or the upper bound we have new array, that is 3, 16, 10 and 20. Okay, so we have divided the two. Now after this, or after the calculation of this mid, I will again call the merge sort. So this is the recursive call. Okay, now the merge sort will be called, and this time I will pass the array A, and the lower bound A will be as it is, that is the value 0, and this time the upper bound is mid. As you can see, merge sort actually accepts whatever you pass at the third value you are going to pass will be considered as upper bound. Okay. So this time, instead of upper bound, that is 8, I have passed on the mid value, that is 4. Okay. So when this function will be called, the actual array it is going to see will be from 15th to the first. This one. Here, I think you people have understand now. And again we'll call merge sort. And for this, I will pass the array, this complete array, but what this function is going to say is from the upper bound, lower bound to the upper bound. Okay. Now for this array, the lower bound will be mid plus 1, that is 4 plus 1, 5, that is from 5th index to the last index. So this second merge sort recursive call will see, or will be dealing with this part of array only, that is from element 3, 16, 10 and 20. So these two calls will, after calling these two, we have reached here. Okay, so we'll not move ahead to the merge function now. We'll first try to divide the complete array. Okay, now for this array, that is from 15th to first, again we'll find the midpoint. Now the index of fourth is again 4. Okay, so 0, 1, 2, 3, 4. So 4 plus 0 is again 4, plus divided by 2 is 2. So from 0 to 2 we have a new array here, that is 15, 5, 24. And now the lower bound for this array, this particular array, is actually 5, that is mid plus 1, 5 and 8. Now 5 plus 8 is 13, and divide by 2 you will have 6.5, so it will be floored to 6. So now from 5 to 6 we'll have a new array. Okay, and then 7, 8 will form a new array. As you can see, I have not changed the index of this second array because we are not actually disintegrating this array. All we are doing is, as the recursive calls will be made again and again and again, what this merge function will be dealing with is smaller and smaller portion of this array A. Okay, so लेट मी ट्रांसलेट दिस इन हिंदी। जैसे इस बड़े एरे को हमने पास किया है, तो जब आप रिकर्सिव कॉल्स लगाएंगे तो उस टाइम पे हम इस एरे को एक्चुअल में नहीं तोड़ेंगे। एज यू कैन सी इन दिस मर्ज सॉर्ट फंक्शन वी आर नॉट डूइंग दैट। ओके, ये पहली जो रिकर्सिव कॉल है मर्ज सॉर्ट की, ये सिर्फ डील करने वाली है 0 से लेके 4 तक। एंड जो सेकेंड मर्ज सॉर्ट की कॉल है वो डील करने वाली है 5 से लेके 8 तक। यहाँ पे ये मैंने शो किया है आपको कि कैसे हमने इसको तोड़ा है एरे को, लेकिन एक्चुअली में ये हमने इसको एक्चुअल में तोड़ा नहीं है। ऑल वी आर डूइंग इज, ये जो रिकर्सिव कॉल्स हैं, ये रिकर्सिव कॉल्स आपके एरे के किस पोर्शन को देखती हैं वो मैंने यहाँ पर आपको दिखाया है। ओके, सो लेट्स गेट बैक टू द fish formal language of our lecture. Okay, I think you people have now understood what I am trying to say. So again, let's come back to this array now. When this, let's say when this one is called, merge sort is called, the value of a is this one, that is same. Lower bound is 0 and mid is 5, that is upper bound is 5. When this function is called, we will again start from here. If lower bound is less than upper bound, yes, 0 is again less than 5. So we'll calculate a new mid, and 0 plus 5 by 2 will again form 2. So again a merge sort will be called, and this time array A will be passed, lower bound will be passed 0, and mid will be passed as 2. So we'll be here. So 15, 5 again will be this. So we are repeating this step here. Okay. So in this way, until there we have disintegrated the complete array into single elements. Let me tell you again, this process will not stop until the lower bound is less than upper bound. Now in this case, as you can see here, for this single element, the lower bound is 0, that is 15, the upper bound is 0. So now lower bound is actually equal to upper bound. In that case, no more recursive calls will be made, and we will be start backtracking in the stack. Okay, will be start getting out of the recursive calls. I think you people are familiar with the recursion now, until now. If not, then please recap it, because we are going to see the stack trace of this merge sort now. So let's go to the next page. We'll come back to this page again to see what is happening in this merge. So until this point, we have disintegrated this array into single element, that is 15, 5. All this that has been shown here with the black pen is the part of disintegration, that is these two calls again and again. And everything in blue here is the merging process, which is being performed by this merge function, which I have described here in this part. Okay, so let's move ahead. Now this is actually the stack trace of merge sort. This capital MS stands for this merge sort, and for this merge I have written merge in small. Okay. Now one thing you will notice here that we have passed only two arguments, that is 0 and 8. I have not passed, as you can see, merge sort accepts A, that is array to be sorted, and its lower bound and upper bound. As you can see, every time we are going to pass the same array A, and inside this merge function also, all we have to pass is the A array that is to be merged, and the lower bound, the midpoint, and the upper bound. So I have omitted this just for the sake of overwriting. Okay, so you can understand A is always there inside the merge sort and inside the merge function. So I have only passed the upper bound, lower bound in merge sort, and upper bound, midpoint, and lower bound in the merge function. So when first call of the merge sort is made, then it will disintegrate, or it will call the two recursive calls. As you can see, each merge sort algorithm will call three more functions for itself. First two calls are the merge sort calls, and last one is the merge sort. So every time a merge sort call is being made to the function merge sort, three more calls will be made automatically by the algorithm itself. That is, two to the itself recursive calls and one to the merge function call. Okay, so this has been displayed here. When a single merge sort call has been made, it will call three more functions, that is merge sort from 0 to 4, from 5 to 8. That now, because uh, until from this point to this point, we have calculated the midpoint, which came out to be 4, as we have seen a few seconds ago. And a merge function called, which we have passed on the lower bound, the upper bound, and the mid value. Okay, so you can see what is happening here. First merge sort will be from lower bound to mid value. So as you can see, lower bound to mid value, and second merge sort call will be from mid plus 1 to upper bound, that is mid plus 1, which is 4 here. So 4 plus 1, 5 to 8. So I think you have understood here what is happening. Now this, when this merge sort function will be called, it will again make three calls. Two will be the recursive calls, and one will be the merge call again. So this time a mid value will be calculated. That mid value is came out to be 2. So first merge, uh, please ignore this bracket here. That's just writing habit. So first merge sort call will accept the lower bound as 0, upper bound as 2. Second merge sort will accept the lower bound as mid plus 1, that is 3, and upper bound, that is 4. And the merge function will have the arguments of lower bound, the mid value, and the upper bound. And again this, because we are going through the stack trace, we are not go inside this particular merge sort first, this call first, because this first call will keep on calling on itself. Okay, so when we are gone here, this particular merge sort will again call three more functions, that is a merge sort algorithm again, or a recursive call, in which the lower bound is 0, upper bound is 1. This will again call two recursive calls and one merge call. First is the lower bound and upper bound as 0. Second one is lower bound and upper bound as 1. And the merge function, that is 0, lower bound, mid, and upper bound. Okay. Now after this point, as you can see in the last there, at this very point to the end, we have called the recursive call merge sort, in which the lower and upper bound values are same. Okay, so you can see here, if lower bound and upper bound values are same, then we will not call anything else. That is it. That is the stopping point of our merge, of our recursive function. So at this point, we'll start backtracking. Okay, so anything that could be returned will be returned by the merge, and will be here now. Again, at this point, the function is stopped. The merge sort algorithm has stopped because upper bound and lower bound has stopped. The values are equal. Again, the function, the merge function actually return back the merged array, and will be here again. Will come here, and in this very recursive call, the upper bound and lower bound are still not equal, and lower bound is still less than the upper bound. So again a call will be made to three functions. First is a recursive call to itself. Second one is also a recursive call with lower bound, upper bound 3 3, lower bound, upper bound 4 4, and a merge with lower bound 3, midpoint 3, upper bound 4. Okay. Okay. So please correct this. This particular arrow will not be there. This particular array should not be here. This merge 334 belongs to this call. Okay, and this call here will have this element, sorry, this element, and this element. I have left this element, I have not written here, so please correct this arrow is not correct. This arrow must not be there. This arrow should actually be to this element here. Okay, I think you have got the point, so please correct this. So at this point, in this very calls, the lower bound and upper bound values are same, so no more recursive calls. The merge function will return the merged array and will be here, and we are out of this recursive call. We are out of this recursive call. Again the merge will merge these two sorted arrays according to its rule, and we'll be here. Now after getting to here again, we'll be inside this very call, second call. So until now we have only moved from this to this point only. So from first recursion call is complete. We are at the second recursive call. Okay. So as you can see, uh, until this recursive call, all of this would have been done from here to here. Please follow the cursor. This very portion has been done by the first recursive calls. Okay, the division, and when the upper bounds and lower bounds are same, we'll start merging. So first this will merge, then this and this will merge, then this and this will merge. Okay, and now we'll start from here. Now second merge will recursive call merge to recursive call has been made. So again, we'll follow the same procedure. I'm not going to repeat that again because we're just wasting our time by repeating that. So by this function here, until when this recursive call has been completed, we are actually done until here. Sorry, we are done by here only. So this portion here, please follow the cursor, has been done by this second call, this second recursive call. And in the end, a last merge function call has been made, which will actually combine this array here, that is this R, and this array here, that is L, and these two will be merged such that the last array will be sorted out. Now we have seen how we are going to divide that. The recursive call will divide the complete complete array, sorry. Now all we have to do is we'll see what is happening inside the merge function. We have seen how we are going to divide the array into equal parts, but we haven't seen how we are going to merge those. Okay. Now let's get inside the merge function. It is quite easy. Maybe it's quite long, but it is actually very easy. So we are going to compare the element by element. Okay. So first, so the first merge call that is to be entertained by the compiler or at the runtime will be the merging of this 15 and 5. Okay, this 15 and 5 will be merged together. This would be the first merge call that is going to be entertained or that is to be executed. Although the calls have been made earlier, but this is at the top of the stack. So this one will be executed first, and it will return this particular array. So let's come back here. Now we'll initialize 3 pointers, that is I for lower bound, j with mid plus 1, and k for lower bound. Okay. Now this merge function will treat 3 arrays, that is a left and a right and another array called b. Okay. So in this case here 15 is left, 5 is right, and this combined form is b. Okay, so don't get confused. So I is pointing to first element of 15 or the lower bound, j is pointing to the first element of right, and k is pointing to the first element of this merged, which is empty right now. Okay. Let me again tell you that all these arrays are not disintegrated physically. We are dealing inside this array only. Okay. Now first we'll test a condition that until and unless I is less than mid and j is less than upper or equal to upper bound, we'll keep on revolving in this loop. We will keep on iterating in this loop. And okay. So what it means to say that if the pointer I is done with this left part until the j is done with this right part, we'll keep on doing this. We are keep on doing some task. Okay. Now inside the if block, while block, we have an if statement first, that is a conditional statement, and we'll check if a of I is less than or equal to a of j. So you can see there, the only array we have dealing with is a. okay, and this A here. So A of I has a value that is that points to 15, and J has a value which points to element 5. So it will check whether the A of I, that is 15, is less than equal to 5, which is not true. Okay, which is not true actually. So in that case, we will not go inside this if block. We'll go to this else block. And in the else block, you can see that B of K will be assigned with a value that is A of G. So a new array is initialized, that is B of K, which is actually of the same length of A, which is empty right now. So we'll start filling the elements of this B array one by one in a way that at the end of the algorithm, all the elements that are inside A are now inside B, but in a sorted manner. So B is just a sorted uh, picture of A, or the sorted clone or brother of A. Okay, now A is unsorted, B is sorted. Now we'll start filling B with. So we first, for the first element, we have compared 15 and 5. We have found that that 5 is actually less than 15, or this element, that is AJ, is less than AI. So in that case, in the else block, as you can say, J will be assigned to B of K. Now K has value 0 now, because we have started from this point. K has value 0. Okay, as you can see, K is assigned with lower bound, and this lower bound has not changed throughout this, and we have passed 0 to the lower bounds in the starting. So the first element will be will come here, will be 5 and 15. So 5 will be assigned first and 15 will be assigned second. Now where these will be assigned, these are assigned actually in this. Now this is the last final sorted form, but imagine that it is not sorted in the first place. So the first element will be here in the first call will be 5. Okay, and again J plus plus, that is J will be moved to the next element. Okay, so J has value of 1. Now it has moved on to 2. Okay, again we'll go inside this while loop. We'll check if A of I, that is 15, is less than equal to A of J. Now J has a value of 2 now, and it is actually pointing to element 24. Okay, now 15 is less than 24. Yes, so in that case, B of K. Also, you can see here that I have forgotten that after every if and else block, you will see a K plus plus. I think I have not done it, but you must do it. You must write K plus plus after each. The last instruction of this while loop must be K plus plus. So we have moved from this element to this element. Okay. Now we are inside this block. 15 is less than 24. So this time B of K will be assigned with A of I, which is actually 15. So 15 is assigned here, and these two are merged now. And the value of pointer I is now incremented to 1. Now I is pointing to 1 and J is pointing to 2. And again K will be incremented by 1, which is we have gone here. Okay, so this will keep on going until we have reached at this point here, that is L and R. Okay, we'll keep on doing this, keep on doing this, keep on doing this. Okay, so now at this point, this will be the last run of the while loop. Let me tell you, this will be the last run of the while loop. Okay, actually this merge call is the last call, that is after this have been done, this we are done with, this we are done with, we have reached at this point. So this merge sort call will return us this particular L. The second merge sort call will return us this particular cell. And I think now you are familiar with how we are going to merge. We are going to compare the values of these two. Like in this case with 5, 15 and 24, the I will point to 5, the J will point to 24. These two values will be compared. 5 is less than 24, so first value will be 5. Next, the value of I will be incremented to 1, j will not be incremented because we are not in the else block, we are in the I block and in the if block. Now 15 and 24 will be compared. Yes, 15 is less than 24. And then again, next element will be 15, and in the end, 24 will be there. Okay, so this is how we are going to merge all that. And same will be the case here in this portion. So when we have reached here, you can see the element wise again, I will point to 1 and j will point to 3 and k will point to 0 from the starting. The 1 and 3 will be compared. We are inside the if block because 1 is less than 3, and the first element will be 1 here, and the value of I will be incremented to 5 now. This it will point to this particular element. Again 5 and 3 will be compared, but this time the j value which is pointing to 3 is lesser than 5, so instead 3 will be copied here in the b, and the value of j will increment to 10. So j is now pointing to 10 and I is pointing to 5. Now again 5 and 10 will be compared. 5 is less than 10, so 5 will be copied, I will increment to 8 and j will remain the same. Again a of I, that is 8, will be compared with a of j, which is 10. Now still 8 is less than 10, so 8 will be copied here and I will be incremented to 1, which is now pointing to 15. Again a of I, which is pointing to 15, will be compared with a of j, which is still pointing to 10. Now 10 is less than 15, so 10 will be copied here. Okay, so 10 will be copied here and j will be incremented by 1. Now j is pointing to the 16th element. Okay, now a of I will be compared with a of j. As you can see, a of I is pointing to 15, a of j is pointing to 16. So 15 is less, so 15 will be copied here and it will be incremented to 24. A of j will remain same. Again the comparison, 24 will be copied here first. 24 is compared with 20 here. 20 will be copied first and then in the end 24 will be copied. And if somehow the I has gone out of its length and we have still remaining elements in j, okay, then in that case we will be inside this if and else block, that is I is less than mid. If somehow I is less than mid now, okay, so then all you have to do is copy the rest of the elements of this j to the element. So what have we done is, so b of k now will be equal to a of j and k plus plus j plus plus. So this loop will go on until the remaining elements of this right hand side will be copied at the end, because we are exhausted with this L. And again, if this j has run out of the upper bound and the elements in this L still remains, so in that case you will copy the rest of the elements of L to the end, which has been done by this line here. Okay. So in this way the merge function will work, and I think we are done with the merge sort now. As I have told you the complexity will be n log n. So I will end this lecture now. Thank you.